In this example, I want to find out the net electric field on this point, point P, due to the presence of these three electrical charges. All of them, they have the same amount, but two of them are positive, one of them is negative. So let's find out. So if we assume that we have the point P here, we're gonna have E1 like this, we're gonna have E3 like this because it's negative, so it's gonna go toward that one, and we have E2 like this because this one is positive, so it's gonna be this way. So I'm gonna have E3 equals to K Q3 divided by R squared, which is 8.99 times 10 to the power of 9 times Q3, which is 100 times 10 to the power of negative 6 divided by R squared. So that will be 8.99 times 10 to the power of 9 times 100 times 10 to the power of negative 6. That will be 8.99 and then next one we have E2. That's going to be exactly the same thing because the distance is the same and the charge is the same, so it's going to be 8.99 times 10 to the power of 5 Newton per coulomb, and E1 is going to be K Q1 divided by R prime squared, which is 8.99 times 10 to the power of 5 times Q1, which is 100 times 10 to the power of negative 6 divided by R prime. R prime is going to be 1 squared plus 1 squared. It's going to be 2, and it's going to be root 2. So it's going to be root 2 squared, which is going to be 2. So it's going to be half of the other. So it's going to be 8.99 divided by 2. That would be 4.495 times 10 to the power of 5 Newton per coulomb. So now in order to find out the net E, I need to decompose the E1 into E1x and E1y. And in order to find it, we need to find out this theta. It is obvious that the opposite and adjacent are the same, so it means that we are dealing with 45 degrees angle. So E1x will be E1 times cosine 45, which will be 4.495 times 10 to the power of 5 cosine 45. Which is going to be 3.18 times 10 to the power of 5 Newton per coulomb. On the other hand, E1y is E1 times sine 45. It's going to be 4.495 times 10 to the power of 5 sine 45. That will give me the same number because sine 45 and cosine 45 are the same. So that's going to be E1x and E1y. So as you see here, E3 and E1y, they are in different direction. Which one is bigger? This one is bigger than E1y, so EY net will be E3 minus E1y. So it's going to be 8.99 times 10 to the power of 5 minus 3.18 times 10 to the power of 5. That is going to be 5.81 times 10 to the power of 5 Newton per coulomb. And EX net is going to be the addition of E2 and E1x. E2 plus E1x That's going to be 4.495. Actually, E2 is going to be 8.99 times 10 to the power 5 plus 3.818 times 10 to the power 5. So 8.99 plus 3.18, that's going to be 1.217 times 10 to the power 6 Newton per Coulomb. So that's EY net and EX net. In order to find E net, it's going to be EY squared plus EX squared, which will be 5.81 times 10 to the power 5 squared plus 1.217 times 10 to the power 6 squared. That is going to give me 1.35 times 10 to the power of 6 Newton per Coulomb. And what is going to be the angle? Angle is going to be, because that's going to be EX, this one is going to be E net, EY, so it's going to be somewhere like that. And theta, let's say theta prime, equals to EY net tan theta prime is going to be EY net divided by EX net, which will be tan theta prime equals to EY net divided by EX net, which will be 5.81 times 10 to the power 5 divided by 1.217 times 10 to the power 6. Going to be 0.477, and theta prime is going to be tan inverse of 0.477. That's going to be 25 degrees. So we found out the E net and also the direction.